Dear students, in today's class we are going to see the concept of splay trees. In the previous lectures we have seen many kinds of trees starting from binary tree, binary search tree, AVL tree, red black tree, splay trees, all those trees. If ever searching, okay, if you going to search a particular value, so it is going to reduce the search complexity, so more or less equal to log n. So if you take binary search tree or AVL tree is a strict height balanced tree. If you do that, then the search complexity is log n. Okay, so all these trees are focusing on searching, but this play tree is focusing on access. Okay, so which are the elements that is recently accessed or more frequently accessed, that will become the root node. Remaining all will be balanced such that it will become its children's node. Okay, that is what we call as in splaying. Splay trees follow the same property of the binary search tree, okay, like insertion, deletion and searching, but it will have one more additional capability, that is what we call as in splaying. I will tell you what is splaying. Splaying means the recently searched item should become a root node. Sir, why it is like that? So for example, if you have a tree, if you keep on searching for one particular element that is in the leaf node, consider it as a leaf node. So the tree is of height say 10 or 20, you need to check every 10 times, 20 times, so that you can access the leaf node. So but what happens in the splay tree is, whichever the element is recently searched, it will push it to the root node, in the concept that which is recently searched will be accessed more frequently. So even if you see that the Google search or any searching mechanism, what we will do is, which are recently searched will be searched more number of times. For example, if you have this Y2K problem, at that particular moment Google search has kept it in the root node. Okay, for example, which are is the latest trending news, will be keeping in the root node. So tomorrow if you have some latest news, so we will push all the remaining nodes to the bottommost, and whichever are very recent will keep it in the first node. So this will improve the efficiency of accessing a particular node. That's why we will call it, that is the use of splay trees. Okay, in spray trees we'll have these many kinds of rotation. We will see each and everything individually. Okay, now listen carefully. So consider we have constructed this binary search tree. You see this is the binary search tree. In the left hand side you see all the elements in the left hand side are smaller and all the elements in the right hand side are greater. So this is same as how we created that AVL tree or those things. We have done this. You can use the concept of AVL tree to create this. Okay, next what I am going to do is, I am going to search for an element 4. If I am going to search for an element 4, so this should become a root node. So this should go to root node. That's the concept called as a splaying. Okay, so if you see this particular tree here, we'll have, see, I will just make a note of it. Okay, here we'll have one more node. This node is the special case. For example, if I want to splay this, splay means this should be the root node. Whichever our parent or the right side of this node will go like this. Okay, so to its right. Okay, so that 4 will become to this root node. You see this here. So you see this 6 and 7 becomes its right node, and the left node it will become the left node. Sir, what happened to this node that is highlighted in the red? Okay, this fifth node will be the left node. Here it is the right node, right? This will be the left node for the last parent. Okay, you see this here. This is the leaf. It will not go to the leaf. That before leaf before node, that is sixth node left child it will become. So this is what we call as a zig rotation. Okay, I hope you understood. Now we will take the one more example. Now you listen to this. This is the constructed AVL tree. This is already balanced. Consider this is the balanced tree. If you see this, we will have the root node as 4. Okay, now I want to search for the node 6. So splay of 6. So what will happen? It should move like this. All the remaining nodes should move to this like this. So it is once again a rotation. Okay, it is a left rotation once again. If you move this, you will see this particular node. This particular node is attached to the node 6. The node 6 should become a root node. So you see this nodes will be at the left. What are the nodes? So 4 and 3 will become the left node, the 7 will become the right node. So where this fifth node will go? Fifth node is the right child of 6. So what we need to do is the left child of 6, it will go to the right child of a 4. Okay, this is what we call as a zag rotation. Okay, so this is the splaying of 6. So whichever the number you are searching is called as a splaying. Splaying means that particular number will be put into a root node. So if you see this example, the number 6 which came to the root node and the remaining nodes are well organized. You see this, the resultant tree is once again an AVL tree. You see this, all the elements to its left are lesser than the root node, all the elements to the right are greater than the root node. So this is the zag rotation that we are going to see, okay, that we have seen. Okay, the next one we are going to see is a zigzag rotation. This is equivalent to right left rotation that we have already seen. Okay, so you see this here. Here I have a tree. This is once again a balanced binary tree. You see this here. All the heights are already balanced. Okay, so now I want to do a splay of 3. Okay, splay of 3. 3 means the root, the node is where it is. It is in the leaf node. It needs to come as a root node. So it means you need to push all these nodes towards, like, okay, you need to pull this. So 7 will be at this position, 6 will be at this position, 4 and 3. Now 3 will become, this is the splay node. So 3 will become what? A root node. That is fine. But what about this inner node? Inner node, this is the inner node is 5. What about this inner node? Here it is the right child. Okay, here it is the right child. So if it is a right child, how it should become? It should become the left child of leaf before the node. Okay, what is the leaf node? Leaf node is 7. Before the node is 6. 6 to the left side you will put. So this is what we call as a zigzag rotation. Okay, one more is called as a zag-zag rotation. Zag-zag rotation. We will see this. Okay, you see this here. This is once again a balanced binary tree. Okay, this is the balanced binary tree. Okay, now I want to do a splay of 7. I want to do a splay 7. So you see this, the splay, it is once again in the leaf node. Okay, you see this, how the splay will work? You need to put it to the root node, right? 7 should be at the root node. Okay, so how it will go? 7 will be at the root node, the left child will be 6, child of 6 is 4, 4 and 3. So this is the inner node. Where this inner node is right now, it is the left child of that particular node. So how it should become? It should become a right child of particular node. So this right child is what? The leafth before node. What is the leafth before node? Is 4. To this particular node, it will become the right child. Okay, this is what we call as zag-zag rotation. Okay, so hope you understood. Okay, we'll go to the next one. So this is what we call as zigzag rotation. So this is a typical case. This will also equivalent to, this is a kind of a double rotation. Let us check how it is done. So you see this here, I want to do a splay of 5. Okay, so if I want to do a splay of 5, this is inner node. Consider this is an inner node. I hope you understood this. Okay, this is the inner node. Previously what we have seen is, we have seen outer nodes. Okay, this in this borders we have seen outer node. So you need to put a inner node to this. This is an inner node, then the node is 5. This is an inner node. You need to put this particular node into the what is it, into the root node. Okay, for that what you need to do is, first you take these 3 nodes, you need to do a right rotation. So this is a kind of thing. Okay, so once you do this right rotation, how this tree will be done means, this 5 will be at this position and 6 and 7. Okay, this will be at this position. So once you do this, this is a zig rotation. Okay, you see this is a zig rotation. If you do this, it will become a linear tree once again. You see this, it become a linear tree. So 4, 5, 6, 7, this is how it will do. Once again I am telling you, the properties of a binary set tree is not violated. You see this, 5 greater than 5 is 6, 6 greater than is 7. So it is in the property. Now what you need to do is you need to find the splay of 5. It means once again you rotate in the left side. Okay, so the root will become 5, next is 4 and 3. So you see this, the splay of 5 contains two kinds of rotation, that is zig of 6 and zag of 4. Okay, so this is the kind of double rotation. First you rotate at this position and you rotate in the left position. Okay, this is zigzag rotation. Okay, next is zig rotation. Here you see this inner node is here, inner node is 5. I want to do a splay of 5. So what you need to do is the splay of 5 is, okay, so you see this, what you need to do, you need to do a left rotation. So that is what we call as a zag rotation. If we do a left rotation, how it will be, 5 will go to this position, 4 and 3. You see this, 5, 4 and 3. Okay, so next what you need to do, you need to do a zig rotation. You see this zig rotation. Zig rotation is equivalent to a right rotation once again, equivalent thing. So you see this 5, the node number 5 will go to the root and the remaining will be at the right node. You see this is the final tree of zig rotation. Okay, zag means it is equivalent to a left rotation, zig means it is equivalent to the right rotation. Okay, zig. Okay, zig means a double right rotation. Okay, that's it. Okay, where we will use it, where we will have catching. So you want to search for some items very frequently without violating, without compromising the search access time. Okay, so you will keep that particular record to the nearest fetching. For example, I have 10 student files. Okay, 10 student files. Okay, one student is very frequent. I want to access that particular file very frequently because he is need more concentration and help. Okay, so what I will do is I will keep that particular file very near to me. Remaining files I will keep it aside. The same thing we are doing it here. So whenever you are using a splay trees, it is more about accessing rather than searching. So access time is will be reduced. How the access time will be reduced? Whichever the elements are very frequently accessed, that will be put it into the root node. Remaining node will be balanced and sent to the left child or the right child of the root node. So this is the concept of splay trees. Thank you. So in the next class we will see B trees and B plus trees. Okay, thank you.